All right, cool. Let's talk about today's lesson. I'll swap to the document camera. All right, first thing you should have written down in your notebooks is the date. Today is the 6th of April. Oh, I should write date down. All right, the other thing you should be writing down is our learning intention, so that way we can keep track of what we are doing. So in this case, what we're going to be doing is defining and processing speed.
Your camera says where? Electric.
So it's our last kind of thing that I need to talk about. And then you guys will be ready to do our little roller coaster project. All right, last thing then is our mahia, our do now. So we have a singer singing, and we're thinking about the energy transformation. So a singer singing into a microphone. So if a singer is singing into a microphone, the singing aspect is going to be your sound. Yep. And then that microphone, remember, is an electronic device, so that sound's getting converted into electrical. And I'm just doing those little arrows to kind of show you guys how I've done that and figured out that answer. All right, so make sure you have that down, and then we can move on to what we're doing for today's notes. And, no, not today's notes, today's lesson, which will include some notes. Yeah, sound to electrical. And if the noise is coming out on speakers, then would it convert it back into sound?
No.
Yeah. Because it's going to go from sound to electrical to sound again. So, like I said, energy transformations. We're not creating or destroying energy, it's just going to be transformed to a different type. So make sure that's written down. The phone I don't want on your table, in a pocket. In a pocket or in a bag. But I don't want it on the table, I don't want it in your hand, I don't want it in your lap. Alright. Can I move it?
No.
Alright. Can I move it now? Yes? Okay. So, what we need to think about is our lesson plan for today and what we are going to speed is and how we calculate it. You guys will have a chance to practice that. Then I will show you guys some videos on ski jumps, and we'll look at the setup of that ski jump, because that ski jump will tie into your roller coaster project, which is how we're going to assess you for the wide world of sports. Basically, what you guys will be doing is building a roller coaster model with a little loop so that the marble rolls down and goes around the loop and then out.
Does that even work?
It does work.
Are you sure? That's not a waffle. Oh, work. Oh. Okay.
It does work.
Wait, I didn't see
Do it again?
I thought we how was supposed to see. Hello. Oh. Why am I so interested?
One more time?
One more time.
Hey.
Yeah, see, I told you. Oh.
AC still doesn't.
Mine's watch
Yeah? So, you guys will be building this roller coaster model. Not right now, but over the next couple lessons. We'll start it today and you'll work on it next week. With this is what's going to act as our assessment. So basically how I'm going to give you a grade for this topic. Okay?
Yeah.
So building this is going to be part of the assessment and also write a small kind of analysis on it as well. And then at the end of the lesson, you guys will have a chance to get started on it. This roller coaster project will probably take the remainder of this term, okay? Cool. But to be able to understand that roller coaster, we're going to also talk about ski jumps. So we can tie it into those sports, and we can also understand how to design a good roller coaster. All right. Off.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, we took it off the other day. We just didn't have a chance to cover it. So 13 and 19 are the two things you can, 13 and 16 are the two things you can tick off. I know, we didn't have a chance to finish the lesson last time. So these two things are looking at calculating speed. Now when it comes to calculating speed, we're going to need to think about it in sections and as an overall average. Cool. All right. So you've ticked them already in the last lesson, but we didn't get a chance to finish. All right. So for today's lesson, to help us learn about calculating speed, I have a worksheet, and I will do some of the questions with you to help you see how to do these calculations. So I'll pass this out, and this needs to be glued into your notes. If you don't have your notebook today and you're working on a piece of paper, glue it onto that piece of paper, so that way you can glue this into your notebook when you get home. All right. So the first thing I need to do is explain what is speed. Probably passed out those worksheets a little bit too early, but that's okay. Just occurred to me that I was going to define. The first thing we need to do is define what speed is. Yeah. So speed is the distance an object travels over a period of time. So let's write that down. All right, so you guys should be writing that down that definition, speed. Distance an object travels over a period of time. All right, write that down. I should see pens moving. Josh, I want to see a pen move. All right, you guys should be writing down that definition of speed. Because you will need to be able to explain what's going on at roller coaster at speed that it's producing. Over the next week. Yes.
Nice.
But he chose sexy guys.
Alright.
So, when it comes to speed, if I want to calculate it, I use the equation V equals D divided by T. Let me explain what each bit of that equation means. So the first thing about that equation, that V is referring to something that we call velocity. Velocity is also referred to as speed. So velocity is just speed in a certain direction. Now, in order to get speed, I need to figure out what my distance is. Now, and I need to divide that by the time it took to travel that distance. What are some examples of units that I could measure distance in? Meters? Centimeters? Kilometers? Yeah, all those work. Millimeters? What are some units of time? How do I measure time? Stopwatch, but what is the units for time? Minutes? Hours? Seconds.
Milliseconds and seconds and.
So let's think of some examples. So some examples of using speed of a velocity of a speed would be, say, for example, 50 kilometers per hour. Or if I said 10 meters per second. Now you can write it with the little slash line, or you can write it as kilometers per hour and have a to the power of minus 1.
I looked up a second and all I see is this way.
All right, I'll leave that up and give you guys a chance to make sure that's written down. I did not take your pen. Oh, let me move that. Give you guys some time to write that down. Let's now look at this worksheet over here that I've given you guys to process. So this here was our define. It gave us a definition, and now what we're going to do is apply that, and we're going to look at some of these calculations for calculating speed. So there are two different things to think about. The first thing is that we have speed in different sections, and we also have the average speed overall for the full track. What I want us to focus on first is just the speed and the different sections. So why do you think in different sections the speed would be different and not the same throughout?
Because it's longer and...
Yeah, it's longer. What do you think I might want to do in this curve? Would I want to go really fast or really slow, maybe? Yeah, I want to go slower because I'm turning. What about this nice straight section? I probably would want to accelerate and go really fast because there's nothing to really curve that I have to worry about, right? So, each section is going to have its own speed. Let me show you guys how to calculate it, and then you guys will do some more practice on it. All right, can we stop with the chit-chat? And ready to calculate. Josh, are we ready? I'm going to start writing again. All right, I will do section 1 as the example, and then you guys will be able to do the other 5 sections. So, if I want to calculate the velocity, I need to take the distance and divide it by the time. So in this case, my distance is 792 meters. So I write that down. And then I will divide it by what number? 9, because you see how it says 9 seconds with that time. I like to write the units down, so that way I can double check if I have the right answer, because my answer should be in meters per second. Because that's what the unit is for velocity. So let's turn on my calculator, and we're going to do 792.
792. Yes. 48.
And we are dividing it by 9. So we get 88. And that's meters per second. What I will do is I'll write it down here because that's where we're collecting our data. So, sector 1, the velocity equals 88. So that's the first thing you're going to be doing. The second thing that you're going to be doing is converting. So, do we often think in meters per second? No, we often think in kilometers per hour. So we need to convert that. the way I convert from meters per second to kilometers per hour is I need to multiply by 3.6.
3.6.
So I would take 88
88.
and times by 3.6. And so if we're thinking kilometers per hour, that car at that section is going 300, and we're going to round up 17 kilometers per hour. I'm just rounding up to make it easier.
What the heck?
That's how fast the car is going at that section.
Well, 3,700.
317 kilometers per hour. Well, this is an imaginary track. All right. Do you guys need another example, or are you okay to try this? You okay to try this? All right. So, I want you guys to answer question 2 and question 3. All the sections are here. I will do number 4 later, okay? So hold off on number 4. You can stop at this point. All right. So, I'll give you a sticker for getting those questions completed, and I'll also give you an extension sheet if you finish early. So, let's talk about one more thing. So can you guys put away the phones, because I need to do that last question with you guys. All right, the last question is thinking about average speed over the whole track. So the way we calculate the average speed over the whole track is I need to know the total distance traveled and the total time it took to travel that. So when I look at these sections here, what I'm going to do is add all of those distances together. So, just trying to move that. All right, so my first distance is 792. My second distance is 598. Third distance is 497. Third distance is 747. Fifth distance is 549. And then my last distance is 600. I add that all together and I get 3,783. And that's meters. All right, the next thing I need to do is figure out my total time. So to figure out my total time, I'm adding it together again. I have 9 seconds. I have 6.5. I have 7. I have 9. I have 9 again, and I have 10. Total is 50.5 seconds. And then we are doing the same calculation as before. We are doing the distance divided by the time. So 3,783 divided by 50.5. I get 74.9. We're going to round that up to 75 meters per second. So that's how I calculate the average speed. Remember, with average speed, we want to take the total distance and the total time. We're not going to go through and average each one of these together because that's a lot of work. All right? Does that make sense? It's different from when we normally average. Okay? All right. Once you guys have that done, make sure you are gluing it into your books. Huh? We will in a moment. All right, but I gotta make sure you guys have some context to it. Okay, so make sure when you finish that you glue that into your books. Can I move it?
No, I'm still ready.
Still ready? All right.
About 2 more minutes.
2 more minutes sounds like a very long time.
Now finish.
All right, so make sure you glue that into your books because these are part of your notes. So I'm going to do the exact same thing. I'm grabbing a glue stick. Actually, I'll freeze that. Huh? Can you take the call? You shouldn't be really taking calls in class. People shouldn't be calling you right now. All right. So I'm just going to glue this into my book. I'm going to fold over the paper. I'm just going to write down that it is my velocity calculations. All right. Cool. Can I move it? I'm waiting for the chit chat to stop so I can move on to the next task. All right. So in a moment, we're going to be watching some videos of skiers jumping and flipping. Now, the reason why we're watching these videos is to help us think about how you will design your roller coaster track. It's a very similar idea. You go down a ramp, and then we want to flip, so the flip is going to be in the loop. So some things to think about when you're watching these videos is to think about the energy transformation and how are we getting that type of energy. Think about how these skiers are building momentum. Think about how the track is designed. And also think about the skiers' body movements when they are preparing for the jump. So there's 3 different videos that we will watch just to give you guys an idea of what this looks like.